So today we are going to learn about the anesthesia machine. I mainly wanted to do this class for the sake of the freshers, straight ABBS students who have come and joined anesthesia, so that they will have a basic idea about the anesthesia machine. They will be able to safely handle the machine. They do anesthesia to the patient. Okay. So without wasting time, we'll go to slides. It will be like a question answers type. There will be a question appearing, and if any of you know the answer, please tell the answer. Don't waste time, because if you keep guessing and waiting, the class will take a long time to finish. So if you don't know, say don't know. Somebody can boldly say don't know, sir. I don't expect the students to know all the answers. So to save time, please say we don't know, so that I can show the answer and proceed. Okay? Is it clear to all of you? Okay. So this is anesthesia machine for PG learning. I am starting with a little bit of history, because we have to know how our anesthesia specialty developed. So the initial 3 or 4 slides will be on the history of anesthesia. So it is more like a general knowledge. So if you know or if you have heard about it, you can answer that. So the first question is, when and where was the public demonstration of anesthesia done? Who did it? What was the agent used? Morton. Very good. WTG Morton was the. He used which an agent? Ether. And date is called the Ether Day or the World Anesthesia Day now. So it was in October 16th, 1846. Okay. The demonstration was done in Massachusetts Hospital, Boston, USA. And the WTG Martin was the person who did it, and he did it with Ether. So which year and who developed the first anesthesia machine, and which country the inventor belongs to? Even if you don't know the year, can you name the person who developed the anesthesia machine? Even now today, the same prototype is being used in a different.
Boyle.
Boyle. What is his full name?
Henry Edmund Boyle.
Henry Edmund Gaskin Boyle, HEG Boyle. Okay, it was in the year 1917. You can see how much of difference or how many years have passed by. First demonstration of ether was in 1846. After that, we have to wait for the 19th century. After almost about 30 years, the first machine was developed in 1917. And it is by Henry Edmund Gaskin Boyle who developed this. He is a Britisher. He belongs to the United Kingdom. Okay. When and by whom carbon dioxide absorption technique was used? And used for absorbing carbon dioxide. Now all of you are using a machine where there is a CO2 absorber, isn't it?
Jackson.
All of you would have by now learned. What is that absorber contain? What is it filled with to absorb the carbon dioxide?
Soda lime.
Soda lime. Very good. Sodium. What is the composition of soda lime? What are the salts incorporated in soda lime?
Calcium hydroxide, water, sodium hydroxide.
Major component. Water. Is the water the major component?
Not the
Calcium hydroxide.
Sodium compound. component is calcium hydroxide. Okay? There is calcium hydroxide, sodium hydroxide, and
Water
silica.
and potassium.
Water is formed because of the reaction. There is no water as it is in that. Okay? Water will be produced when there is a exothermic reaction with carbon dioxide, and that water will be retained. When you allow it, it will become dry again. Okay, so the three main compositions of that soda lime is calcium hydroxide, sodium hydroxide, and silica for hardness. Otherwise, it will be like a powder. So to make them into small rounded particles, silica is added. Okay, granules. It's so called the granules. Of course, we have to learn about that in detail. It's one of the exam questions also. So that we will talk later. But who who did the carbon dioxide absorption technique? It was by in 1921, after 17, when the machine was produced. In 1921, a person called Sir Ralph Waters of USA. He was the one who introduced the first carbon dioxide absorption technique in anesthesia. Okay? And he was made to use this because he used an agent called cyclopropane. This cyclopropane is a very, very powerful inhalation agent, gas like your ether and chloroform in those days, but it was very expensive. So to save the cost of the use of cyclopropane, he was discussing with a friend of Dr. Alf Waters, who was a chemist. So he was telling that to use cyclopropane, my patients have to spend a lot. So I'm thinking how to reduce the expenditure. Then the chemist asked him, when you administer this gas, do they breathe it out also apart from inhaling it, or they retain all the gas? Then Ralph said, no, they breathe out more than half of it. And he said, then why don't you reuse it? And he said it can't be done because there will be carbon dioxide present in the exhaled air. That will be again breathed. Then he said, I will tell you a technique to remove the carbon dioxide from the expired or exhaled air, and you can reuse the cyclopropane. So that is how the concept of absorbing the carbon dioxide and removing the carbon dioxide from the exhaled air and breathing then once you remove the carbon dioxide, it becomes like a fresh gas. So whatever cyclopropane is coming out of the patient's body will be re-inhaled without the carbon dioxide. And the equipment that we used is called the Waters 2-1 Pro canister. And if you have not seen, this is the Waters 2-1 Pro canister, because it is called 2-1 Pro because gases go both directions. So when the patient is exhaling, if we go back to this is the canister with the soda lime, and if we go through that, all the carbon dioxide will get absorbed, it will reach the reservoir back here, and the fresh gas flow will be coming here from the machine. So when the patient takes the next breath, fresh gas as well as the exhaled gas without carbon dioxide, both will go to the patient. And so because the gas travels in both the directions, it is called the Waters 2-1 Pro canister. And this was the first carbon dioxide absorption technique used in the history of anesthesia. Okay? So that is about this. Can you identify this?
Sir, oxygen flow meter.
Ah,
Sir.
is it written oxygen here? This is a flow meter. Okay. Don't mention the gas unless you find the name in that. Okay.
Yes,
So
sir.
this is a flow meter for a gas. Okay. So what is shown here? When was it added in the anesthesia machine? Again, the year is not important. So you have identified it is a dry bobbin flow meter. It is called this is the bobbin that will be there. It will flow up when you open the valve here. So it is called the dry bobbin flow meter, and it was added to the anesthesia machine in 1933. So before that they were giving it by other machines. So it was only 1933 it was added. What is PISS? And who designed it and why? What is the expansion for
Woodbridge, sir.
PI?
Woodbridge.
Huh?
Woodbridge, sir.
Woodbridge is the person, very good. But what is the expansion for this
Pin
acronym?
index safety system.
Pin index safety system. Excellent. And why was it designed or added to the machine?
Sir, to avoid wrong cylinders being connected.
Excellent. To prevent the mounting of a wrong cylinder in the yoke. The place where you push the machine is called the yoke hanger.
Yoke assembly.
Yoke hanger assembly or yoke hanger, whatever way you want to call. So the expansion for this is pin index safety system. Woodbridge designed it to prevent mounting a wrong cylinder on the yoke hanger. And see, and what is shown in this picture? Here you are seeing a to-and-fro canister. Similar to that, we have, some of you would have seen this thing being the modern anesthesia machine.
Closed circuit, sir.
Huh?
So
Here
closed
it is
circuit.
called to and fro because the gases go both directions. What will you call this? In which way
One way
gases go?
circuit, sir. One way,
Huh?
sir. One way
Not
flow.
one way. Goes in a circle. So it is called a
Circle system.
circle absorber. Okay, gases go in one way, correct, but they come in one direction and then go into like a circle, goes again and again. So it is called a circle absorber. So this is a circle absorber canister with a soda lime which has a color. What is the color? What is the name of this color?
Phenolphthalein.
It's pink color. What dye is called?
It's a phenolphthalein dye.
Phenolphthalein, excellent. It's called the phenolphthalein. And there is another color called ethyl violet. These are the two color indicators that are incorporated. So how will you know why this color has been added to the soda lime?
To know
What is
the
the purpose?
exhaustion
Why
of the
can't it be
soda
white?
lime.
To see whether it is really functional or it has become exhausted. Because when it goes on absorbing the carbon dioxide, it will become turn color from pink to white. That indicates that it has lost its capacity to absorb the CO2 and you have to change, remove the used ones. If all of them have become white, you have to remove them and refill them with a fresh one so that the efficiency of CO2 absorption will be maintained. And this is a two-chamber canister. How much of soda lime can be filled in one chamber? These are all, of course, these are all other questions we will discuss before Viva. Okay. And who is the person who designed that? Here it is Ralph Artus, one pro canister. Who designed the circle system or circle absorber? So what is shown here is the circle absorber, CO2 absorber system. The person who designed it is called Brian Sword. Okay. His name is Brian Sword. It was introduced in 1930. Okay. So 1921 was to and fro canister, and almost after a decade, got the circle system introduced into the system. Now, what is shown here? This is a continuation of the first question in the last slide. So that is the clue.
Sir, first demonstration of anesthesia, sir.
Demonstration of ether anesthesia at Boston, Massachusetts General Hospital. Okay.
Yes, sir.
This person is W.T.G. Martin. You can see he is holding the canister or the ether application instrument in his hand, and it has been introduced into the patient's mouth. The patient is inhaling ether from that, and the surgeon is taking out a swelling from the submandibular region. So this was a public demonstration of ether anesthesia by Morton at the Massachusetts General Hospital. And this person is W.T.G. Morton. And this is the instrument that we use. This is called the ether inhaler. Okay? In the sponge, we soak the ether liquid and the air will come through this. And this portion will go into the mouth of the patient. They will be spontaneously breathing and taking all the ether vapor into his lungs and they will become unconscious and get anesthetized. So this is the replica of ether inhaler used by Morton. What is this building?
Sir,
So,
Massachusetts.
Massachusetts
Hospital.
University.
it is written there Massachusetts Hospital, but what is the name of this building? Can you see something
Ether
here?
Hall, sir. Ether
It's
Hall.
called the Ether Dome. Okay, so Ether Dome at Massachusetts Hospital to as a monument for this particular discovery in anesthesia. Okay. What was the name given by Morton to ether when he applied for patent rights and what was the composition? He didn't use ether as such. He combined it with some other liquid and wanted to get a patent out of it.
Sir, he's lithium. Sir.
Lithium, very good. He called it as lithium, which is a mixture of ether and oil of orange. Okay, so that is what. But this oil of orange has no role in producing any anesthesia. But he wanted to make it little more pleasant to smell. So he added this oil of orange. But ether is the main component, and this combination he called it as lithium. So he didn't call it as ether as it is. What is written on Morton's tombstone? After he died very young. He lived only up to 46 or 48 years. He died. But his demonstration and its discovery, the great boon to anesthesia and patient. So they wrote a very, very appreciative message on his tombstone. After his death, they buried him, and they usually, in the Christian burial, they will have a tombstone writing the details, which is called the epitaph. What was written in that? Any idea? I just want I included it to show how people appreciated him. So before whom? That is before Morton, in all time, surgery was agony. By whom pain in surgery was averted by his discovery, because ether is a very good analgesic. So it is not only an anesthetic agent, it had a good analgesic property. So pain was totally averted, and since whom science had control of over pain. So these are the three lines written there. Before whom in all times surgery was agony, by whom pain in surgery was averted, since whom science has control over pain. Now what is done here?
Induction using chloroform, sir.
Chloroform maybe, but what is the method of application? How are they applying it? It is called open drop method. Okay, open drop method of general anesthesia, where they pour the liquid anesthetic agent. It may be it was chloroform initially, but later ether was also used. Okay? These two agents were the commonly used agents in the beginning era of anesthesia, and they use something like this. What is this? They use, because they cannot pour this liquid directly over to the patient's skin and face. So they poured it over something like your
Shimmer
face
bus
mask
mask.
which you are using nowadays. But it was designed by somebody else. Okay?
Shimmal musk.
It is
Shimmal
called
bus.
Shimmel Bush mask. Okay? It's called Shimmel Bush mask. So this is the frame of that Shimmel Bush mask. So this is the metal frame for, this is the name, CHIMEL Bush mask. This is the name of the mask. And here you can see there is a white gauze over this, whereas here it is not there. Okay? So that is it. This is just the basic frame. You can fix the gauze over this. Okay? And then what is the purpose of that gauze?
Protect the
Now
eye,
you are
sir.
pouring the liquid.
The eye
Can this
protection.
liquid directly go into the lung?
Yes, sir. It can go, sir. It can.
Liquid can go. Then what means you have never seen ether being poured. You can never see a liquid on the surface. Immediately, what will it become?
Vaporize, evaporate.
It become evaporated and it will
Evaporate.
become a vapor. Okay, as soon as it comes out of the bottle, okay, that get vaporized and immediately it become a vapor. It will become a gas. You cannot see it with your eyes. And the direct liquid, if you pour it on the skin, it will be irritating. So they poured it over a gauze piece, and by have this gauze, is it a tight cloth or it is a fabric with a lot of holes? Now you are seeing every day the gauze being used for dressing the wounds after surgery. Is it a close knit woven cloth or is it a loosely woven with a lot of there are a lot of gaps will be there. That
Gaps
will
there,
give
sir.
an increased surface area for vaporization. Okay. So the more the number of the gas pieces, it will have more area for vaporization. Okay. So this is another modification of the same thing. Now let me see how observant you are all. This is the frame that I showed you, original symbol was passed. There was a modification done by somebody. And can you find what are the differences you see this improved version compared to the old one? Just look at the picture for a minute or two.
Sir, see better.
So there's a
See.
sling. There's a sling
Huh?
on the newer mask.
The sling. This is a clamp actually. The dotted line that is here. This clamp which has been lifted up to insert this gauze piece or the metal steel woven gap. This can be fixed by that. But apart from that, can you see something else?
Seal better.
Oxygen
So the
pores.
There is a nipple
pores,
for
sir.
connecting oxygen, and these are all the holes through which the oxygen. Who said that?
Sir, me.
Who said about oxygen?
Sir, I said, sir.
Vijay
Your
Lakshmi.
name. Why are you scared?
Lakshmi, sir. Vijay Lakshmi.
I just want to appreciate you. Who
Vijay
said that
Lakshmi, sir.
oxygen?
Sir, Vijay Lakshmi.
Vijay Lakshmi. Why don't you say that? You are very modest. Huh? Okay, good. So this is the nipple for connecting oxygen source. This was later modification. Original symbol was this was no oxygen facilities available. So they improvised oxygen delivery so that patient will not become hypoxemic. Okay. So this is a metal mesh fixed on that. Provision to deliver oxygen is there in this picture. And the dotted line depicts the metal clip to open the position to remove the mesh and clean it later times. Now, what is the name of this bottle? This is the bottle what he is using here to drop the whatever agent, whether it is chloroform or ether, anything it can be. But this is the bottle he is using, or people were using in the earlier days. This is the bottle they were using.
Junker's chloroform bottle, sir.
Junker is also one of the ways of doing it. Junker also did that, but the name of this bottle is Bellamy Gardner Ether Dropper. Okay. So, what is the purpose of this bottle? It has a long tube going in and a short tube going out. What is the purpose?
Sir, one for oxygen and one for
One
inhalation.
for air to go in, not
Air to go,
oxygen.
oxygen,
When you
yes, sir.
drop, air will go and replace whatever vapor is or the liquid is coming out. Okay, so that further vapor can be formed. Yeah, otherwise, what will happen if you have only one tube? After a few drops, it will stop. It will not flow continuously. So there should be room for some displacement. So air will go in and displace the vapor and the liquid coming out. So the liquid portion will be dipping inside the fluid here. Okay. So how does it work? It is a brown bottle of 6 ounces capacity. It has a rubber stopper with 2 metal tubes. One long dipping into the liquid ether and other short one to allow air to replace the vapor used. Okay, so that is how this machine works. Why it is in brown color? It could have been white.
Photosensitive.
Photosensitive, very good. What will happen if ether is exposed to the sunlight and UV rays? What reaction will take place?
Sir, exothermic reaction, sir.
Exothermic reaction, wild gas. Okay? It will react and form peroxide, which is a toxic agent. Okay? So ether, what is the formula of ether? Anyone tell the formula of ether? Actual chemical name of ether is, earlier it was called diethyl ether, but even before that it is ethyl methyl ether. So it has got a ethyl component, it has got a methyl component. What is the formula for methyl? All chemistry, school days chemistry.
CH3.
CH3. Ethyl,
Sir, methyl is
CH3,
CH3, sir.
Okay.
Yes, sir.
So there is an ethyl component, there is a methyl component, and in sunlight it will get decomposed to peroxide. Okay? That is a toxic component. So that is why it all, both chloroform and ether will be stored only in brown or amber colored bottles. Okay? Right. But photosensitive is a correct answer, but what exact reaction is there? Now, what is an anesthesia machine? Which is the first machine marketed? What is the purpose to evolve anesthesia machine? In the open drop, the previous slide, what I showed you, do you have any control over how much of ether you are giving? Except that you can stop on and off. But do you know what exactly the concentration, what is the percentage of ether or chloroform that you are giving? Do you know anything about that in that method?
No, sir. No, sir.
No. So you don't have a control over the concentration inhaled by the patient. And do you have any facility to give oxygen except the modification I showed you?
No, sir.
No.
No, sir.
So to take care of all that only, the anesthesia machine was developed. Okay. So anesthesia gas machine is a device which delivers a precisely known but variable gas mixture, including the anesthetizing and life-sustaining gases like oxygen. And original boil was made by a company called Foxter. Okay. Then later on, it was developed into more newer and old versions with advanced ventilators, which are the biggest difference between new and old. Earlier, we were manually ventilating the patient, but modern machines save you the trouble of ventilating your hand, give freedom, so you can perform other functions. So that is the first machine that was marketed was Boyle's machine, original Boyle's machine. Okay? But before that, a person called Nagaswamy in USA, he developed an anesthesia machine almost 5-6 years before Boyle developed the machine. But Boyle saw that prototype and then collaboration with this company, he made it and marketed it first and patented it. So that is why Boyle got the name. But even before that, it was manufactured or it was formed. So the anesthesia machines, how do they are classified based on the gas flow? And can you give examples for those?
Sir, intermittent and continuous, sir.
Fantastic. What
Sir,
is
continuous
the
boils.
example for intermittent?
Intermittent Gautami and Mekison's machines. Sir.
Mekison's. Entonox and Mekison. Okay. I mean,
Okay.
Entonox and Mekison's for intermittent. That is only when the patient takes an inspiration, the gases will flow from the machine. So that is what is called the intermittent flow. During expiration, it will not flow. On the contrary, in continuous gas flow machine, gas flows during both inspiration and expiration. The examples of all the modern machines that we have, once you open the flow meter, irrespective whether the patient is breathing in or breathing out, gases will continuously flow. Okay, so they are called continuous flow machines. What changes were incorporated in Boyle's machine from the original version?
So oxygen and nitrous cylinders were added.
Cylinders were initially there was only one cylinder, then they made it two cylinders version. So these are all the changes, of course. These are all the exhaustive. So in 1917, he introduced the machine. Then vaporizers with the bottles were added between 1920 and 26. And 1930, the plunger device in the vaporizer bottle. So these are all very old machines. Many of you would not have a chance to see or had a chance unless when you go for exam, some hospitals will still retain the old machine and show you and see whether you have ever seen such at least in the pictures. In 1933, the dry bobbin flow meter was added, and 1937, rotameters replaced the bobbin flow meter. Various safety devices were introduced. So this is the typical Boyle old machine. This is the flow meter assembly. Okay. If I can see, there are how many flow meter tubes are there?
3, sir. 3.
Ah, three in use. One has been made dummy. Okay. One has been blocked. Can anyone make a guess and say what was used here and why they have removed it? And what are all the other agents that were kilometers are there for that? This is a very old machine. This I have used as a PG in 1976. Like 50 years ago, I have used this machine. What is this flow meter? This orange color.
Cyclopropane, sir.
Excellent. This is the cyclopropane which was in use in those days. And this is what Ralph Waters was using, and he wanted to save and produce this to and fro. This blue, all of you know. What is this?
Nitrous oxide, sir.
Nitrous oxide. White,
Air.
Air,
oxygen. Air is black. Okay.
Okay.
Oxygen is white. Okay. This is oxygen. This is nitrous oxide. This is cyclopropane. And what this could have been, which they have removed and done it. They were using carbon dioxide also. The fourth flow meter tube, the second one on the list was carbon dioxide because they thought in those days CO2 accumulation, what will it do on the respiratory center?
Sir,
It will.
increase.
When
It
you
is a
have,
trigger for the breathing, sir.
it will stimulate respiration to wash out the carbon dioxide, isn't it?
Yes.
So they thought when the person is depressed after anesthesia, if you allow him to breathe through carbon dioxide, this carbon dioxide will stimulate the respiratory center and make him breathe more efficiently and bring back his consciousness. That was the concept that they were thinking, and they were using this. But instead of making the patient breathe more aggressively, it produced a carbon dioxide narcosis. The patient became more drowsy. So they removed it, realizing their mistake. Okay? And these were the two oldest vaporizers which were used in the Boyle's machine. And the names are written here. What is the name of the agent written? Are you able to read?
Ether and trilene.
Ether and trilene. Okay. So why ether bottle is bigger and trilene bottle is smaller?
More widely used, sir.
More?
Widely used.
Which one is widely used?
Ether.
Then why did they have trilene also in that? Supposing among the two, if one agent is very potent compared to the other, will you use it in a larger bottle or a smaller bottle?
The potency of ether is less than compared to
Less
the.
than the trilene. Okay. So trilene is more potent, but if you use it in a higher concentration, it may cause very severe respiratory depression. So what they did was make it volume available less by using a smaller bottle. Even if you by mistake give a larger, you will not have enough agent there. Okay? Whereas ether is comparatively safer. So even if you give more, there is a old saying, an average anesthetist with average skill cannot kill a patient with ether. That much of safety is there with ether. Okay? And And then this, you can see two silver rods projecting here. I'll just spend a few minutes to explain all these things to you, so that in case you happen to see this machine and get questions on that. Nowadays, how do you deliver the sevoflurane or your desflurane or your isoflurane to patient from
Tech
their
vaporizers.
paper? Huh?
Tech
Which one you
vaporizer.
operate to open the gas to come out?
The dial is there.
Dial. You have the dial in front or in the top. Isn't it? You press that knob and then rotate it. So here, this is the lever for operating or opening the gases to go in so that it can pick up the vapor. Okay. In this down position, all the gases coming from the flow meter will very straight away go. They will not enter the bottle. You straight go. It will not enter trilene. It will not enter ether also. Okay. But if you lift the lever, you can faintly see the white markings. Are you able to see that? So the first marking, second, third, and fourth marking. Four markings are there. So this is a partial allowing gases into the machine, into this bottle. So first position, second position, but there is no exact percentage you cannot calculate, but it will arbitrarily allow the gas to go into the bottle and pick up the vapor. And if you lift the lever full, all the gases will go into the bottle and maximum vapor will come out. Okay, so to adjust the concentration that you or the percentage of vapor that you want to deliver, you have to lift this lever to the desired position. And you can see another silver projection with the round knob here. What is this called?
So some valve.
This is 1930. In this line, you can see plunger device in vaporizer bottle. Okay? So what is this? This is actually has been pushed into the liquid. Okay? You can lift it up, it will come out little more. Okay? So by pushing this, what they did was you allow the gas to go into the surface of the liquid. Supposing you have ether up to this, if you just open the lever, what will happen? The varying amounts of fresh gas flow will come, pick up the vapor on the top, and then go out through the excretory lid. On the contrary, if you put the plunger, some of the gases will come into the liquid and start bubbling through that liquid and pick up more vapor and come. So whenever you want to deliver the highest concentration, you must open the lever to the maximum position and also push the plunger into the surface, into the depth of the liquid, then you will get the maximum concentration. And what is this? You can see these two here.
For refilling, sir.
This is just a stopper or a cork to open and fill. You don't have any sophisticated filling like what you have in your modern tech vaporizer. You have to simply lift this, put a funnel inside and pour the liquid, or directly pour the liquid from the bottle into that and close the cork again. Okay? That was the filling port with a stopper for this. Okay? So these are the two bottles were there. Is there any compensations here for temperature or flow, or do you get any exact percentage?
Nothing, sir. Nothing.
Nothing is there. Okay, so these are all very primitive, totally unsafe vaporizers which were used, and because the agents were safe enough not to kill the patient, we were able to manage with this, and we were carrying on. But later on, they found that this is a very wrong method of delivering the gases. They completely removed all that, and nowadays we have the most sophisticated vaporizers which can precisely deliver whatever concentration that we want. And if you come a little more here, you find there is a knob-like thing with something written here, and this is called the circuit selector. So by turning this knob, you can go for what is called the open circuit, where you can attach your Nagel's or Mapleson A circuit, for spontaneous respiration, or you can go to what is called the closed position and go to the circle system for controlled ventilation. And can you see something here in a semi-on position, something like a white knob with a flat metal portion?
Yes, sir. Yes, sir.
Now, what is that? This is the oxygen flush knob here. Okay, in the old machine, this is the oxygen flush knob. I will show you a picture little later in a very close-up view. So that is about the old Boyle's machine. Now I am showing you some pictures. Can you identify who this man is?
Boyle.
Boyle. He is the Henry Edmund Gaskin Boyle. Okay, identify the person and the equipment. He is Henry Edmund Gaskin Boyle, plump-looking man. And this machine, what is this? This is the first machine or the prototype of Boyle machine. This is how it was in the beginning. Later on, it was converted into that. Okay, so modified version of Boyle's machine. So this is the first prototype machine. In 1917, this is how the machine works. Okay, right. What are the functions of an anesthesia machine? Again, the same question as we asked earlier. So it provides oxygen, accurately mixes anesthetic gases and vapors, enables patients ventilation, and minimizes anesthesia-related risk to patients and staff. Okay, that is the function of anesthesia machine. Now, what is the basic design of a continuous flow anesthesia machine? For a machine to deliver gases continuously, what are all the things that you require? This is just like a common general knowledge question. You don't need to have any deep knowledge for in anesthesia.
Sir, continuous fresh gas flow must be available. Sir.
You first of all have a source for the gases, isn't it?
Yes.
You must have the gas being delivered from some source that should come to the machine, and that should be routed through the flow meter to decide how much flow you want. And that should be delivered to the patient through a breathing system. Okay, so that is what the basic design consists of: pressurized gases supplied by cylinders or pipelines. This is the first requirement. And then it goes to the anesthesia machine, which controls the flow of gases by the flow meter before passing them through vaporizers to pick up the vapor of the anesthesia gases or the liquid and delivering the resulting mixture to the patient through breathing circuit. So there should be four components. One is the gas source. Second is the control of flow by flow meter. Third is a vaporizer to mix the anesthetic vapor to the gas. And fourth is the breathing circuit to deliver that. So these are the four basic components of any anesthesia machine, whether your workstation or even better than that, if you deliver some or create some newer machine also, these are the four components which are required. To understand that basic concept, you will be able to understand whatever sophistication the machines are made into. Now, what are the five main components still preserved in modern anesthesia machine from the time of Boyle's? So, based on the same question, you have a high pressure supply gases. There is a pressure gauge of oxygen and nitrous oxide or other cylinders or pressure reducing valve. Then there is flow meter, which you have even in your latest modern workstation also. Without flow meter, you cannot deliver gases. Then there are metal and glass vaporizers and breathing system. Here I told you about the four components. The fifth component added here is the pressure gauge and the pressure reducing valves. That is because the gases are supplied at a very high pressure and they cannot be directly delivered to the lung. What will happen if you supply gases at 2000 psi?
Barotrauma.
Barotrauma. You will rupture the alveoli. So it is very highly dangerous. So we have to reduce it to safe limits. That is done by the pressure. So from the earlier question, one more thing you have to remember is all the machines require a pressure reducing valve and also a gauge to show what is the pressure that is being there in the machine as well as in the airplane. Okay. So this is the basic model. Now I am showing a close-up picture of the wheel, this machine. What is this wheel called?
Anti-static, sir.
Anti-static. Okay, good. Anti-static is the rubber which is coated here. But what is the name for the entire wheel? This is not only used in your anesthesia machine, it is used in so many, even your trolleys in the theater or the dressing trolleys used in the ward. Everywhere you can find this. And in the industries also they use it. Is there any particular name for that? This is called the caster wheel. Okay? Anesthesia machine fitted with 4 caster wheels and a close-up view of one wheel. Now, by looking at this, what is the advantage you can have by it? Why they have fixed this wheel to this and not a wheel like your car or your two-wheeler?
Sir, swivel mechanism is there, sir. It has a stopper.
Mechanism is
It
not
has
the
a
correct
stopper.
word, but it is angle, rotation angle. How many degrees it can rotate this wheel? See, there is a stem here. There is a ball bearing attached. You are making the wheel attached to that. So if you have a, can it rotate all round? No, this can rotate 360 degrees. Unlike your car or your two-wheeler or a cycle wheel, which will rotate only 180 to 200 degrees. Whereas this will rotate all 360 degrees. Okay, that is important because in a smaller theater, if you want to push the machine, it can directly go into only the direction like your car wheel. You have to push the machine several times front and back to get it into a position. Whereas if it has got a 360-degree rotation, it can be easily moved into any position you want. Okay? So this wheel can rotate 360 degrees and help to move the machine in all directions within a small space. What is the difference between these wheels and the old and the new machines? That is where this first answer is coming here. Okay, this is this rubber, black rubber that you see is called the anti-static rubber, which is fitted to the older machines. But if you see the now modern machines, you will not find this black rubber beading. It will be a regular hatching color design or something like that. Why they have removed that anti-static beading from the newer machines? What is anti-static? Have you heard of the term called static electricity? Yes or no?
Yes, sir. Yes, sir.
Yes, sir.
What is the understanding of static electricity? When two substances come together, rub or come closer to each other, there will be a electric current. Protons will be passed from one to, electrons will be passed from one object to the other. Okay, there will be a current flow. That is called the static electricity. In the earlier machines, it was required to fit with them with an anti-static rubber because all the agents that were used like ether, chloroform, except trilene, were all highly inflammable gases. And they were using mostly spontaneous ventilation. So all the patients' exhaled air will be in the OT. And if there is an electric spark occurring because of the movement of the wheel and rubbing it on the floor, there can be fire and explosion. So that is why they were using rubber which has a higher carbon content, which will not cause the static electricity to happen. But modern anesthetic vapors, your isoflurane, sevoflurane, desflurane are all not much inflammable like your older agents. So the need for fitting them with anti-static rubber is not there. So the old machines had anti-static rubber wheels to prevent generation of static electricity since flammable volatile agents like ether and chloroform were in use. But the modern agents are not inflammable. Now you are going to see the machines from their origin to a little bit on what improvements were done. So this is the original machine, Boyle's machine, what was used. You can see it has a provision. There is a nitrous oxide cylinder attached here. This is the. How do you know this is a yoke for oxygen? There is no cylinder fitted here, but how the OT boy will know that he has to fix only the oxygen cylinder here?
Pin index, sir.
In index,
Pin index, does the OT boy know the pin index? Can you see the difference here and here, what I am showing?
the shape.
Color.
The pressure gauge is here white in color. Specifically, if you see closer, it will be written oxygen. Whereas here it is blue in color. Color coding is there. Okay? So even unlettered people or people who don't have education, they can know that they have to fix only oxygen here and not other gases. And of course, they won't be able to fit it with the pin index also. So this is the only pressure gauge is there here. So it's a very old type of Boyle machine, which is called the cadet, Boyle cadet. And there is a provision to mount one oxygen and one nitrous oxide cylinders. And there is already one E-type nitrous oxide mounted in place. Okay? All you have to do is observe this and tell me what are all the features you are seeing. That's all I am asking. Describe the features. You just see what are all the things that are present and you answer. What is this? Are you able to see my pointer going around?
Yes, sir.
What is that?
Flow meter.
Flow meter. And what is these two knobs? One for nitrous oxide and one for
One for
oxygen.
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 So which nowadays in your regular machine, where is this oxygen knob? The second position or in the first position? The OT machines that you are using now, do you find the oxygen knob in the first position
First
or
position.
nitrous oxide?
First position. First
First
position, sir,
position
oxygen.
only oxygen. Earlier it was first position and second position for nitrous oxide. But sometimes they change it, thinking that if there is a crack in the oxygen cylinder, which will produce a hypoxia system, that concept was proved wrong, and again they have switched back to oxygen in the first place, nitrous oxide. And what is the third gas you have in the modern anesthesia workstation?
Air, sir.
Air also is there. So you have 3 flow meters tube. Here only there are 2. And any other vaporizer you see here? What is this? Any idea? Are you able to see something, a small bottle with a metal top?
Yes, sir.
Can anybody identify and tell the name of that? So the description is there are 2 cylinder provisions. Then there is a flow meter assembly which has a dry bobbin with the oxygen nitrous oxide knob. And the third one is the Goldman vaporizer, which is called the Goldman vaporizer, which has a very small glass container in which you can unscrew this. It doesn't have a filling port or anything. What you have to do is unscrew the whole cup-like thing and pour the liquid and again screw it back into the same position. And here you will have a lever rotating going in the horizontal direction. Whereas in the earlier ether and trilene, I showed you a lever which will go up and down. Here the lever will go along the circle. So it will go horizontally and you can turn again here the concentration we do not know. It is just written 1, 2, 3, 4 positions will be there. So this is also not a calibrated one to deliver the exact gases. And this was mainly introduced when halothane came into use because halothane was a very, very powerful agent compared to both ether and trilene. So whenever an agent is very potent, you require very small quantity. So to safeguard that, they made it a small container to hold that liquid. Okay, so that is and you can see a small projecting things here. Can you identify what is that? Of course, if you see the close, it is a oxygen pressure hose is there coming and getting attached here. You can see coming from the wall, and there is a breathing circuit which is coming out from the common gas outlet, which is hanging here, and just above the breathing circuit you have a valve called the APL valve. Okay? So this was the oldest machine, Boyle's machine. After the prototype I showed you, it is very primitive. This was the improved version. Then, because they found that having one cylinder is risky, because halfway through, if the cylinder becomes empty, you have to deliver the gases with hypoxia because oxygen will not be available and you have to replace that. So they introduced provision for two cylinders, the later machine. Okay? So this is an improved version of Boyle cadet machine. This has provision for two oxygen and two nitrous oxide cylinders. That was the improvement that they made. And this has two vaporizers. The old Trilene vaporizer is also there. And then what is this vaporizer? Nowadays you are using vaporizers of this model only. But this is a very old model. Just like the cars having a newer model every year, vaporizers also had their models improved year by year. So this is a,
Hello.
what are the modern vaporizers called? TEC. They are called tech vaporizers.
Yep.
Tech means temperature compensated vaporizers. Okay. So this is the oldest temperature compensated vaporizer for halothane when it came into market. Earlier they were using it in Goldman where the percentage was not known. But to make it more safe, we introduced this first tech vaporizer for halothane so that precise concentration can be delivered. And again, you see there are only 2 flow meter tubes here, one for oxygen and one for nitrous oxide. No air was used in those days. Okay, and there is still a trilene because it was a very good agent, non-inflammable. So they were still using it even after halothane was introduced. So there is one tech vaporizer. This is called the back bar. This whole rod is called the back bar into which you can fix all the vaporizers. Okay, and this provision is used in both spontaneous and controlled ventilation by what is called the open and closed method, which I showed earlier. And there is a double chamber soda lime canister here that was introduced 1930 itself, and an oxygen flush valve is present here and there is an APL valve. This unit I showed that close-up look later in one of the slides. And this is present next to the tech vaporizer. So the oxygen flush and the APL valve both are incorporated here next to the vaporizer. Whereas in the modern machines, all of you know the oxygen vaporizer will be in the front panel itself in this sort of positions. Okay, and so we come to still more improved version here. So you have all the central pipeline connection as well as cylinder provisions are there. And you can see these are all the modern vaporizers. And still this has got only flow meter for two gases, oxygen and nitrous oxide. But what is the difference? In the earlier machine, we had the pressure gauge right over here to the hanger yoke assembly itself, just proximal to the cylinder attachment. But here what has happened? All the pressure gauges have been incorporated into a panel like this. So earlier machines were showing only the pressure inside the cylinder that has been mounted. You will not know what is the pressure that is being delivered from the central pipeline outlet. If you are having a wall outlet, you do not know. But in the modern machine, they have provision to show both the cylinder pressure as well as the pipeline pressure. So that if there is a drop in the pipeline pressure, an alarm will come and you will immediately open the cylinder and start using it so that patient will not become hypoxemic or like by cutting off one of the gases. So the pressure gauges are arranged in a panel in front, and there is a display for both cylinder as well as pipeline pressure. That is an improvement that has been made. And again, there are two dry bobbin flow meters fitted with the assembly, and they are color coded. And two tech vaporizers are there in the back bar. Okay, one may be isoflurane, or one may be uh, sevoflurane. And the APL valve on the extreme of the back bar. This is the APL valve and auxiliary flow oxygen. So this is the, you can see this is the auxiliary flow. What is the beauty of this auxiliary flow oxygen supply? Even in all your modern anesthesia workstations, all of you are having this.
Yes, sir. It's there.
Yes,
Yes.
It's
sir.
there.
Yes, sir.
What is the major difference or what is the major safety feature of this auxiliary flow? Think over it. When I come to the next slide, I will tell you if you don't know the answer. Okay. And oxygen flush valve present in the front body. You can see here, this will be the oxygen flush button. So it is not situated at the top like earlier model. It has come to the front. And single chamber soda line. Here there is no double chamber. You find only a single chamber soda line. And the major difference between the earlier machines is, what is this? I have already written here.
Hello, system.
என்னப்பா படம் பாக்குறீங்க, எழுதிருக்கீங்க, இந்த படிச்சுட்டு பதில் சொல்ல மாட்டேங்கிறீங்க.
Hello, system.
Number 9, what I have
Bellows,
written
bellows.
here? God, I have written the answers here. Are you able to read this line or not?
Yes, sir.
What is the number 9 line here?
Anesthesia ventilator fitted
Ventilator
behind.
fitted behind the canister. Okay, this is the anesthesia ventilator. This is a major addition to the newer machines. Okay, and what is this on the top? I have already shown the
Monitor,
answer.
sir.
Monitor,
Monitor.
sir. Monitor, sir.
Multi-parameter monitor placed on the top shelf. And what is this? Are you able to see here?
Sir, for fluid
Sir,
hanging.
for fluid,
This
sir.
is a hanger. Hook stand for left side for hanging bottles. Okay. Abba. And these are all 4 drawers to store items. You can keep your laryngoscope, you can keep your IV set, you can keep your endotracheal tubes. So all of them can be stored here. So these are all the improvements in the newer. But more newer or more sophisticated than this is your latest. I think all of you will be very, very familiar with this because you are using it day in and day out in your OTs. So what is this? This is your
Anesthesia workstation, sir.
anesthesia
This
workstation.
workstation.
So what is the one most important difference between the earlier machines I showed you and your workstation? I think all of you should answer this.
Sir, ventilators
Monitor, sir.
integrated, monitors and everything is integrated.
Ventilator ஏற்கனவே காமிச்ச ஸ்லைட்லயே இருந்ததுமா.
Sir, monitors is integrated, sir.
Monitor also I showed you in the earlier machine. Is that the major difference? Do you require any electrical power for the earlier machines to work?
No, sir.
No.
No. Whereas your workstation, if you don't operate this switch, will your workstation start functioning?
No, sir.
So this is the major difference. It requires both electrical and pneumatic supply for your workstation to function. Whereas all the earlier machines were simply operated by the pressure from the
Pneumatic.
gases, pneumatically operated. Whereas the workstations have electrical, pneumatic and One more. What is the other component that has been added in the workstations? Electronic also. Okay. So there are three components which have been added and made this workstation more sophisticated is electrical, pneumatic, and electronic components. Because sometimes your flow meters don't have that flow meter tube at all. You have electronic flow designs. So the modern workstation is operated by all the three: electrical, electronic, and pneumatic. And earlier machines were only by pneumatic power. Now, what are the safety features in workstation? They have been added. This is a common question. The examiners will ask you. So for want of time, I'll straight away go. It has an auto test facility. How many of you have seen this being done? Because nowadays most of the theaters, the OT technicians perform all that and keep the machine ready by the time you come into the OT.
Sir, we'll
But
check it,
as
sir.
a
We'll check it, sir.
pardon,
Usually we'll check it, sir. Machines.
are you taught
Yes,
how
sir.
to do that?
Yes, sir. Yes, sir. We check
Yes,
it daily,
you
sir. We
should,
check it
all
daily.
of you should know how to check for the auto testing and find out any leak or anything present or not. And it is all touch screen. So you have to go next. The machine itself will say this first test is complete, satisfactory. Go to the next second test. So it will give you so very easy if you read the screen and proceed. It is not a very difficult thing to learn. So the first and foremost thing, the machine itself will test the safety for slips and disconnection and tell you to proceed or not. The second thing is it has a flow meter for oxygen, nitrous oxide, and medical air. Okay, so all the machines nowadays have, and some of the Western machines they have removed the nitrous oxide at all because it causes what is the risk of using
Greenhouse
nitrous oxide?
warming, global warming,
Global
greenhouse.
warming. Very good. So they don't want that to happen. So if you see the newer machines used in the Western countries, totally nitrous oxide will not be there at all. So they use only oxygen and medical air. And there are thin flow meter tubes for low flow anesthesia. Okay. Some of the I'll show you the later pictures. Instead of a single tube, you have two tubes for each gas. You will have a first tube. What is the difference in these two tubes? What will be the graduation or marking if you have a twin tube flow meter?
Decimals in one tube and
First tube will have from 50 to
numbers.
100 ml to 1 liter maximum. Okay, so that you can give very low flow like 200 ml, 300 ml also can be given. So you have the lowest, earlier it was 100, now they have even reduced it to 50 ml, and the maximum that can be delivered by the first tube if the bobbin is raised up to maximum 1 liter. Whereas the second tube will deliver from 1 liter to 10 or 15 liters. Okay, so that is how their tube is designed for low flow anesthesia to prevent the theater pollution as well as cost, economy, everything. And there is a hypoxic guard to prevent hypoxic mixture. How many of you test for hypoxic guard? How do you test for the hypoxic guard? You said you have learned how to
But
check
sir,
the
when
machine.
when we turn the nitrogen on, nitrous oxide on, the oxygen also will switch on.
Very good. So that is the first thing that you do. Supposing you turn first nitrous oxide only, oxygen also will automatically go. Is that the way to test for hypoxic gas?
Sir, once we turn the nitrous off, also oxygen will be there, sir. 1.1. I'm not sure, sir. Sorry, sir.
Hmm? Yeah, correct way to test hypoxic gas. Can someone tell me how to do that? You said that nitrous oxide, if you first switch it on, automatically oxygen will also go. Agreed. But that is not the way to test for hypoxic gas. What is the correct way to test for hypoxic gas? Nobody knows, or can I tell the answer? English
I don't know, sir. Don't know, sir. I don't know.
Open both oxygen and nitrous oxide to equal volume. Say 3 liters or 5 liters. Open oxygen first and then open nitrous oxide also to equal amount. Okay. Then close oxygen first. Then what will happen to the nitrous oxide?
Sir,
You
it
are
will also
opening both
it should come down,
oxygen
sir.
and nitrous oxide to the equal value. Okay, then first you
Sir.
close oxygen completely. What should happen to the nitrous oxide
It
bobbing?
is also should be off
Should
completely.
immediately come down to zero. Okay, because you cannot deliver nitrous oxide alone without oxygen. So that is the way to test for hypoxic gas. Okay? Open both oxygen, say 2 liters of oxygen and 2 liters of nitrous oxide. I will open. Okay, then I will close oxygen first. Immediately the nitrous oxide bobbin should come to zero. It should not flow. That is the correct way of testing because you cannot deliver a hypoxic mixture. Okay? Opening nitrous oxide first and then immediately oxygen coming is a safety feature, but that is not the way to test hypoxic gas.
Yes, sir.
Hypoxia means when there is a hypoxia, the other gas should not flow. That is the meaning of hypoxic gas. So open both the cylinder, both the valves to equal volume. First close oxygen, immediately nitrous oxide to fall to come to zero. Am I clear? Is clear or
Yes,
not?
sir.
Yes
Yes,
or
sir.
no?
Yes, sir. Yes, sir. Yes, sir. Yes, sir.
ஐயோ கடவுளே மூஞ்சியும் பார்க்க முடியல கேக்குதான் கேட்கலையாம தெரிய மாட்டேங்குது. And there will be an audible oxygen failure alarm. And it has an anesthesia ventilator which can provide so many modes of ventilation. The earlier method, you can deliver only a set volume. You can set the idle volume, the spread rate, and IE ratio. இவ்வளவுதான் பண்ண முடியும் earlier machines. But modern anesthesia ventilator, you have volume control, pressure support, SAMB, whatever you have in your critical care and ICU ventilator, all that can be done in the modern workstation ventilator also. And it has a provision to fix the text vaporizers with interlocking. It prevents simultaneous operation of the two vaporizers at a single time. And it has scavenging system to prevent OT pollution. And it has inbuilt multi-parameter monitor. And it has an auxiliary oxygen flow meter which can work even if no electrical power is available. This is the question I asked in the earlier slide. Okay, so here you have an auxiliary flow meter. There are two here. Can you see two auxiliary flow meters with control knobs? What is that for?
So,
One for oxygen and one for air. Okay, they are giving provision even for air also. And they can operate even if the power is not on. That is the main safety feature of that. So you don't require electrical power for delivering gases or oxygen through the auxiliary flow meter. So many features are there. Now, how many of you have seen this arrangement in your hospital?
So central gas supply
seen,
unit,
sir.
sir.
Seen, sir.
This is
Seen
called the
gas.
manifold, central manifold room. So what is shown here is this is a manifold room for storing the gases. How does it work?
If the central supply gets cuts off, these cylinders will start gets
So you
functional.
have one on use, okay, and one in reserve. So the first one in use will start delivering gases, and if these cylinders become empty, automatically these cylinders will open and start delivering. Okay, so this is called the use bank. This is called the reserve bank. Okay? Not reserve bank of India, but reserve gas bank. And there is a central panel here which will show what is the pressure in the bank A and bank B. And if there is an empty cylinder here, it will give an alarm, as well as it will show a visual display. A red light will burn saying that the bank A is empty. and immediately the technician will come and remove all the empty cylinders and fit the new cylinders. Okay. So one bank will be in use while the other bank is kept reserve. And the one in use gets empty, the reserve one will automatically open because low pressure here will automatically allow this gas to come out from the full cylinder. So that is the sensing mechanism is there. And there will be a visual display in the central panel. This is the central panel indicating the empty bank, and we have to replace all the cylinders. And this is the panel in a close view to see what is the pressure and how the connections are made. Now, what is shown here? And what is shown here? So, this is the right method of storing the cylinders. You should not dump them one on top of another. Okay? Actually, they all should be kept vertically standing with a chain to prevent them falling and injuring the persons who are operating this. And this is the correct way to transport the cylinder. You should have a trolley like this where it should be chained and then removed. These are all things which were done in the earlier days. Nowadays you don't see that because everywhere you have the central pipeline. And what are the sources of oxygen supply for OT or ICU or critical care? From where all you can get, what are all the methods of supplying oxygen to the various areas which require oxygen supply?
Sir, central oxygen supply, oxygen
Central
cylinders.
oxygen from the cylinders. Okay, one. Then
Sir, cylinders attached to anesthesia machines.
that is a very small one that we reserve usually. But for the entire hospital,
Pipeline system, sir.
yeah, pipeline, where the pipeline is only a delivery tube. But what is the source? When you enter MEOT, you see a big thing on your right hand side
Liquid oxygen, sir.
near
Liquid
the
oxygen
emergency.
storage tank. Liquid
What is
oxygen
that?
tank, storage tank, sir.
Ah, liquid oxygen plant. Are we not seeing it every day?
Yes, sir. Seen it, sir.
Yes,
Ah,
sir. Yes, sir.
so the gaseous oxygen in compressed gas cylinder, the liquid oxygen, which is also called the cryogenic oxygen, and oxygen concentrators. Nowadays, because this oxygen, liquid oxygen and gaseous oxygen are all quite expensive, major hospitals which require a lot of oxygen for their patients, they create their own oxygen from the atmospheric air by taking the ambient air, removing the nitrogen and getting the pure oxygen for supply. So they are called oxygen concentrators. Earlier we were using it in small portable machines like for patients who require home oxygen therapy. We still have oxygen concentrators available in a small model, but huge ones are now being installed in major hospitals. So these are the three sources of oxygen supply. This big cylinders like this in manifold room, or the cryogenic liquid oxygen plant, or oxygen concentrators. Okay. Then comes the next one. What is shown here and where is it used? This is cryogenic or liquid oxygen plant. Very good. Where is it used?
Sir, big hospitals, sir.
In big hospitals which require a lot of oxygen daily. Okay. So this liquid oxygen plant, it is ideal for hospitals consuming large volumes and not easily met by the small manifold room large cylinders. But large cylinders, there should be always a reserve. Here the manifold itself is used as a reserve, but for daily consumption, liquid oxygen will be ideal. It will work out cheaper. What is VIE?
Vacuum insulated
Vacuum
evaporator.
insulated evaporator. Okay, that is the mechanism by which this liquid oxygen works. Okay. So, what is the temperature and pressure of the liquid oxygen in the tank?
Pressure is around
Is
2000
it hot or
psi.
cold?
148 degree Celsius, sir.
Plus or minus?
Minus 180.
Minus, sir.
It's very cold. So it is minus 183, not 143. It is minus approximately 183. And what is the pressure?
2000 psi.
2000 psi is our regular gaseous cylinders. 16 to 35 bar. Pressure can be between 16 to 35 barometric. What is the color of the liquid? I mean, color of the liquid oxygen.
Blue, sir.
It's called pale blue. Very good. Clear pale blue. This is the color of the liquid oxygen. Okay? How many liters of gaseous oxygen is produced by 1 liter of liquid oxygen?
660 liters.
660. That is the quantum of air present in a E-type cylinder. Total quantity of oxygen present in a E-type portable cylinder is 660. 860 liters. So 1 liter of this liquid oxygen will vaporize and become 860 liters of gaseous oxygen.
Okay, sir.
And what is a PSA generator and how does it work? What is the expansion for PSA? It's called the pressure swing absorption technique to separate. Earlier, what I told you as the third possibility of creating oxygen from atmospheric air. Okay, oxygen concentrators. They work on this principle of what is called pressure swing absorption, where they separate oxygen from the ambient air. So the ambient air will be sucked in and pressurized and pass through a cylinder or a container having compressed air forced through an absorbent filled tank. And the absorbent they use is what is called a zeolite or activated carbon, which will selectively trap unwanted gases like nitrogen and other noble gases and allow the target gas, oxygen, to pass through as a high purity product. So this is the pure oxygen generator, PSA generator. So these are all the various tanks. So air will be sucked in by a compressor and then pass through these tanks, which will contain the zeolite or activated carbon, and you will get oxygen manufactured at the hospital plant itself. This is the latest technology which we use by many hospitals. Now, what are the classes of piping in pipe distribution system? Whenever you have a central supply, you have to deliver that gas from the storage area to various parts of the hospital. Okay. So for that, you must have an idea how this pipeline should be laid. Even though you are not engineers, in future when you become the HOD of anesthesia or an important administrator, you should have a knowledge how these gases will have to be delivered to various corners of the hospital. So for that, you should know how the pipelines have to be laid.
Main
Okay.
lines,
Main lines,
risers,
fantastic. Pipes connecting to the
risers,
source pipes to branch lines. Then you have
risers,
risers, vertical pipes connecting to the main line. Then
branch lines.
branch lines, very good. Lateral lines which connect to the room or group of air, very good. So these are the three methods. So from the source area, main lines will take first, and then there will be vertical branches going from that, which is called the riser. And from risers, it will go to the individual area like OT, ICU, endoscopy room, wherever you want, you have to take the branch from the risers. So this is the picture that you can see. So this will be the various locations. Right? So liquid oxygen tank is there, vaporizer is there, and these are all the manifold. So manifold will be always a reserve whenever you have a liquid oxygen plant or other things. And from these sources, the main lines will go. Okay, and it will go to the various areas. You can see wall outlet in OT points, and this goes to endoscopy room. Here is the endoscopy room, and this is the critical care. So from these sources, Main line will have to go, then riser line will go, then branch lines will go. So this will be the rough diagram which you have to simply remember. Make sure that the fittings are done according to this. And what are all the alarm types needed for the pipe distribution system? So there are
Master.
3 locations: the main area, then the risers, then the branch. So should you have alarm at every level, or is it enough to have alarm at only one level?
3 types of alarm, sir.
What are all
Master
the 3
alarm,
types? Master
master
alarm, very
alarm,
good.
area alarm, and local
Area
alarm.
alarm, local alarm. Who is that answering?
Tanya, sir.
Anya. That means you went through dots and dots yesterday.
Sir, I read.
Very good. Dots and dots gives all these things. That's a very wonderful book. All of you have to read. And what are the installations best performed during the TDS? First, initial blowdown. Whenever you allow the pipeline to be fixed in the hospital, first thing, it should be totally blown down of oil-free nitrogen, with oil-free nitrogen to clear any accumulation of dust or anything. Then we should perform initial pressure test, then test for cross connection. For example, you may have a central supply for oxygen, you may have a central supply for air and the nitrous oxide, and all the gases should go individually in the designated lines. It should not get contaminated or it should not get cross connected. So that is very, very important. And pipeline purge test should be done, and standing pressure test should be done. And what are all the hazards or problems in PDS? That is piped distribution system. Logically thinking, what is the
Inadequate
commonest problem is
pressure
low
can be
pressure.
there.
Supposing the liquid oxygen gets evaporated and it is not refilled in proper time, then the pressure will start dropping. So first thing is inadequate pressure. Then there may be leaks in the pipeline, just like having a leak in our
Contaminant.
household water supply or other pipeline. There is a pipeline leak also. Excessive pressure sometimes can happen, and the alarm problem. When will excessive pressure happen? How is the high pressure in these cylinders are reduced? You will have a reducing valve.
Shut off
Various
valve, sir.
places. So if these valves malfunction, then you will have excessive pressure, and that will cause blowout of the pipeline or damage to the instrument. And the alarms may malfunction or fail to form, and cross connections are also possible during the fixation itself, and gas contamination can happen, and fires can happen, and depleted reserve supply also can happen. So these are all some of the problems in the pipe distribution system. Now what is shown here?
Sir, pressure gauge. Sir.
Pressure gauge.
Is
a
the
pressure
pipeline
gauge in
pressure
the machine?
pipeline meter pressure meter, sir? It can.
Huh?
It shows the pressure in the pipeline, sir.
Pipeline, oxygen, medevac, nitrogen, nitrous oxide, medical air. So this is the panel to show the pipeline system pressure, not inside machine. If you go tomorrow and see in your theaters, everywhere in the main OT outside, you will find these machines. If you are using all these gases, you will find there will be a display. This has normal pressure, green light will be there. If there is total empty, it will give a red light and also produce an alarm. Okay, as the pressure is dropping, it will show an amber color. Okay, so this is a warning system. This is the warning panel or alarm panel for to show the storage status and give an audible alarm. What is this? This is again a component of
Valve,
pipe.
sir.
Huh?
They are shut off valve, sir.
Shut off valve. Excellent. Very good. Who said that?
Tanya, sir.
Tanya again. Fantastic. So this is the lever. Whenever you want to do some repair in a particular location, you cannot close the entire source line, isn't it? So every area where you want to do some maintenance work or repair for a leak correction or anything, individually every area should have a shut-off valve. So this lever, if you make a little half turn, it will close the valve and that will show the pressure coming down to zero. Then you can safely go and repair the leak or whatever it's having. So this is control valve outside or shut-off valve outside for service and repair. Okay. What is cracking a cylinder and why is it done? This is one of the common questions examiners may ask you if they show you
There
a
might be
portable
some,
cylinder. Huh?
there might be some dust in the outlet, so
Ah.
prevent that will do cracking of cylinder
Ah.
so that there is no increased pressure build up in that cylinder.
Very good. That is the answer for why is it done. But what is cracking a cylinder? How do you do that?
Slowly open the stem, sir.
Open the stem and immediately close it. Okay. So that is
Yes.
called the cracking of cylinder. Before a cylinder is fixed to a hanger yoke, during replacement, the valve should be opened slightly and closed immediately. Okay. This action is termed cracking. It is intended to clear the valve of dust or dirt that might otherwise enter the regulator. Okay. So 50 marks for Anish and 50 marks for Anya. Sorry, this is the way. You just open the cylinder, push, you allow the gas to go out, immediately close it. Okay? That is what is the method of doing cracking. The examiners commonly ask you this question, especially if they have a small portable cylinder in the Viva exam as a special equipment, they will ask you this question. Right. And what is this? I have not typed the question and the answers for this. Just orally I am asking. Have you ever seen this?
Sir, hanger yoke assembly.
Huh?
Hanger yoke assembly, sir.
Hanger yoke assembly. Where do you see this entire thing?
At the back of the anesthesia machine.
Anesthesia
The
machine.
back side of your daily working anesthesia machine. Okay. Now in the back side, what are all these things? If you have gone and observed and seen the back of your machine every day, what are
Power
these?
connector, sir.
This is electrical power outlet with a control switch. Excellent. Okay, 3-pin power outlet, and these are all. What are these three things?
Sir, central pipeline connection, sir.
Pipeline connector. So what is that connector called?
Sir,
Diameter index.
DISS.
DISS. Have you heard of that?
Yes, sir, DISS.
Yes.
Just like PISS, here DISS, diameter index safety system. Okay, that is how the central line will be connected. And these are all the spare cylinders. Okay, and can you see something very small? I will show you another picture of that. If you see back cover and these are all the names of the spa. This sometimes you see in the back of their machines. What is this for? And it will look like this. So these are all the communication or communicating for data collection. Okay, so this is called the data system communication ports, which by attaching the line for this, you can transfer all the data to the computer system. In the modern machines, whenever you want to collect the data, then transfer the entire data to the central computer system from where you can take it later on. Okay? And which important equipment? Now we have had a general idea about all the machines. Now when you enter the OT, what is the first thing you look for? In a new OT you are entering. First, suction. Is it the one? Everybody agree with that? Before using anesthesia machine, what is the important thing you should look for, whether it is available or
The
not?
power supply is connected or
Oxygen,
not.
Huh?
oxygen.
Power
Power
supply
supply.
is there or not? Okay. Sometimes, even without power supply, it can work on battery.
O2 pressure, sir. Oxygen pressure in the
O2 pressure. Okay. Anything else? There is no O2 at all. What will you do? You have started a case, suddenly O2 becomes completely empty. For
O2
some
cylinder.
reason, there is some fault.
Sir,
And you have
ambu
intubated the
bags,
patient.
ambu
Huh?
bags, sir. Ambu bags.
Ambu bag. Yes. The most important part of the pre-use anesthesia workstation checkout is verifying the presence of ventilating resuscitation bag. So every theater should have this ready. And as a safe anesthesiologist, whenever you go to a new place or a new OT or in your own regular OT, first thing you should check is whether there is a ambu bag readily available or not in case there is a oxygen failure or ventilation failure. You must be at least able to ventilate the patient with atmospheric air. Okay. So this is the first thing. So ventilate and oxygenate first, troubleshoot later. That is the dictum that is given by Miller. So if there is any possibility that the workstation or breathing circuit is a potential cause of difficulty with ventilation or oxygenation, switching to a self-inflating bamboo bag is an appropriate decision. This is golden words that you have to remember for the safety of all your patients. Okay. Now, if you enter a OT for the first time, how will you trace the path of the gases and vapors? From which point you will start checking? You are going to a new hospital for the first time. You are entering the OT for the first time. And there is a pipeline supply, there is a workstation, it is a very sophisticated hospital. So, but you want to make sure that everything is in order. So, where will you start your checking before giving anesthesia to the patient? Supposing you have to give DA, you want to use the machine also. Where
Sir,
will you start?
from the manifold, from the central supply unit till the anesthesia machine.
Not manifold, you don't have to go to the manifold room, but if it is a wall outlet, you have to first start from there. Okay? Right, very good, correct. So, what are the things that you will check at the wall outlet?
Sir, tuck test for the.
So,
Sir,
the
is it
first thing
connected
is
properly?
source of gas supply. See whether it is coming from a cylinder which are attached to the machine. Some small nursing homes, you may not have a central pipeline outlet. So you may be going to practice in a small area, you get a posting in a PHC in the nearby hospital, that's a 50 nursing home with 5 beds or 10 beds. They may not have a central supply. They may have only the cylinder attached or mounted into the machine. So first identify what is the source of gas, whether it is coming from a central pipeline or whether it is from the cylinder attached to the standard tube assembly. Okay. Then what is the second step? So this is the first thing. Okay, central pipeline outlet is there. So what is this person doing? You can see a hand doing
Tuck
something.
test, sir. Tuck
Making
test.
connect.
Excellent. Okay. So he is pulling that and seeing whether it is properly inserted or not. So tuck test you should perform. Pull at the hose and see whether it is properly fixed. Then what is the next thing?
Sir,
Whenever
pressure
you
loss
have
to
a
check
central
the
supply,
pipeline
what is the
pressures.
thing that you should do in the second thing?
Pressure
See
gauge
whether the
pipelines.
cylinder is available or not. Open the cylinder and see the pressure, and which should always be a reserve available. Okay, so check the cylinder available. And then third is oxygen failure devices, hypoxic guard testing, as I told earlier. Then you go to the flow meter, the beginning of low pressure segment. Okay? So from here you go to the flow meter. Here you can see the twin tube flow meters. And you have the knobs These are available, oxygen, nitrous oxide and air, everything is available. So open them and see whether the bobbin flows correctly and then close them. Okay. Then from here, what is the next thing? Your regular machine, what is the next attachment in this back bar? Daily use பண்றீங்க. Every day after the flow meter, what will be there in the machine, man?
Breathing circuit.
Breathing.
Straight away breathing circuit. Don't you give
Vaporizer.
sevoflurane or desflurane or isoflurane?
Vaporizers.
Vaporizer
Vaporizers
will
will
be the next one. Okay.
Yes, sir.
I'm tracing the pathway. No, you are starting from the source, going through the pressure gauge, going through the flow meter, going through the vaporizer. If you don't want to use the vaporizer, well and good, you are not going to open it at all. But the next connection will be to the vaporizer. And then finally from the vaporizer only, we will go to the breathing circuit. Okay. So these are all the steps from the source pipeline or cylinder, reduced by the pressure gauge, come to the flow meter. If you want to use a volatile, you pass the flow meter gas into the volatile, vaporizer, and then deliver it to the patient through breathing. So these are the 6 steps. Source of gas, high pressure reduced by the pressure gas, oxygen failure, safety measure, then the gases flow through the flow meter, flow through the vaporizer, finally comes out through the common gas outlet at atmospheric pressure. Okay, so this is how the whole gas travels and reaches the patient. Now, showing some pictures here. Can you identify what is this?
Terminal units, sir.
Oh, this is called the pipeline wall outlet. Every theater you have this. Okay, maybe fixed in the wall or it may be in the ceiling pendant. I will show you the pictures other side. Now, what are all the safety features in this? This is the common question the examiners will ask you. Can you fix an oxygen hose to a nitrous oxide hose?
DIS, sir, diameter indicator.
First of all, you have the color coding is there. Even
Quick
for
connectors.
an uninitiated person, you will know that white means he has to connect oxygen, and the hose color also will be the same. Have you seen that?
Yes, sir.
And the nitrous will have the blue and the air will have the black. So all color coded. And this is what is this portion called?
Quick
Where they,
connectors. Quick
Body, sir.
connectors.
this is not the quick connector. This is called the Schrader valve. Okay, self-sealing valve or a Schrader valve. So color-coded wall outlet is what is called the self-sealing valve, which is named after a person called Schrader, S-H-R-A-D-E-R, Schrader valve, where the probe will be inserted. This is the hose with the probe. No, normally these are the ones which are inserted into that. Okay, so color-coded high-pressure hoses with diameter specific probes. So the diameter varies for each one. That is why you cannot insert a oxygen probe into the nitrous oxide or nitrous oxide into the oxygen. Okay? And this is the probe in close-up view. This is how it will look like. So this portion goes into that. This is the hose which will be fitted here like this. Metal. This is called the ferrule. 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 Okay. So close-up view of the probe. And what is this? If you don't have this in the theater, you may have this. What is this called? This is the sealing gas outlet, color-coded hose. Okay. Some places you may have this wall outlet, but modern theaters they have sealing to prevent. Why? What is the advantage of having a sealing hose instead of a wall outlet hose? Practical. Will it run on the floor? Sealing outlet hoses?
No, sir. No, sir.
It will be directly coming to the machine. Whereas this wall
Yes.
outlet, this has to come on the floor and then come to the machine. So there is chance people can trip and fall on that. Okay. So that is the reason why they have switched over from the wall outlet to the ceiling outlet or ceiling pendant system. Okay. So earlier it was all like this only. So because of this problem of excess length you require, and that will run through the floor to reach the machine, and there is a possibility people can stamp on it or slip and fall on it, and the wear and tear will be more. So that is the reason why. And what is this?
Index system.
This is the pin index block for connecting the hose to the machine. Okay. So in the hanger yoke, instead of the cylinder, if you are fixing this hoses, then this the same pin index mechanism will be there. Pin index for oxygen nitrous oxide. This is the whole pin index block. This is called the block which can be fitted into the hanger yoke. What is this? If you don't fix it on the hanger yoke, on the back of the machine, you can fix it with, this is the diameter index safety system. Okay, you can just insert it and then thread that screw into that position. Okay, so this is the oxygen nitrous attached to the back of the machine and not on the hanger yoke. And what is this? So here it is coming
Called a
directly from the
ceiling
ceiling.
mounted pendant, sir.
This is called the ceiling pendant. Okay, so you have a length coming down. So you can attach your hoses here, as well as you will have electrical points on this side. This may be commonly seen in many of the theaters here. Do you have this in your OT?
Yes, sir.
Yes. And this is the, what is this? This is the answer you gave earlier.
Yeah,
Quick
sir.
connection.
It is like another wall
Terminal
outlet
units,
with a
sir.
quick connector. Okay, so wall outlet newer design, which is called the quick connector. You have to just insert it, and just like this hose, you can connect it simply. Okay. Now, what is shown here and what is done in A and B is the question. Because again, the same question. Tuck test for wall outlet and tuck test for the back of the machine connection. Okay. And tracing the gas supply from wall outlet to the machine. That's what we do. And tuck test is done to secure the connection. This is picture A. Okay. And, what is this picture show you?
Hanger yoke assembly.
Hanger yoke assembly. You have two cylinders already fixed. What is the third one? Doesn't have a cylinder. Can it be left like this without a cylinder?
Yoke block can be placed there.
Here, sir.
You have to place a yoke block. Fantastic. Okay. So there is a oxygen nitrous oxide being fitted into that. But we should never leave anything open like this. There is a yoke block. I will show you the picture later. One of the slides. And this is the back connection going into the machine. If there is no under BIS connection in the newer machine. What are all these things?
Pressure.
Various gas pressures.
Pressure gauge for oxygen, nitrous oxide, and air. Okay. And what are the safety features here? Pressure gauge also has some safety features.
The pressure relief valves. Okay.
Gauge, I am asking about that measurement showing. The gauge shows the pressure inside the cylinder, Lema. I'm not asking what is the mechanism of pressure reduction. That is the role of the pressure regulator.
Pressure
But
regulators.
what is the feature in the gauge that you are showing here? What is the red for?
Check valve, sir.
This is not valve, ma. This is a display for showing the pressure inside the pipeline or in the cylinder. Okay, the needle is moving. Okay. So what is this red line that is there in all these things?
Low pressure. The
drop in pressure
drop
to
in
the
pressure.
dangerous zone. Okay, may take care and improve or open a new cylinder. This is what is indicated. Now here you can see oxygen is in a safe limit. But as the needle comes down when the oxygen is being used from the cylinder, when it comes to the red zone, you will have to be alert. Earlier it used to silently go to zero. But nowadays, as it touches the zero, I mean red line, you will have an alarm or you will be cautioned that the pressure is dropping. We have to take care to see, ask somebody to check and remove that. And everything is color coded and the name of the gas is also written there. Okay? These are all the safety features, color coding, name of the gas, pressure drop zone. This is called the pressure drop zone in that. And modern machines, they give both the pipeline pressure supply, both in numbers as well as in the gauge form, and cylinder pressure is also given, and that will be in the front panel itself. You don't have to search over the cylinder area. Now, this is a very important knowledge that you have to know. What is shown here?
Cylinders.
This is what is
Pin
the
index
name for
safety
this
system.
entire
Pin index.
metal thing here?
Pin index.
Cylinder valves.
This is called the valve block, cylinder valve block. Okay, it is not just a valve; it is a valve block, and this is the one which controls the gas to be released from the cylinder. Okay, so oxygen is in the nitrous oxide cylinder valve block. The components of this gas cylinders. Supposing they show the entire cylinder in the exam and ask you to name the parts of this. Can you name the parts?
Cylinder valves. Neck.
Cylinder valve block. Don't say cylinder valve alone. Cylinder valve block. Then where is it fitted? Which part of the cylinder it is fitted?
Shoulder.
Where is your head on your body?
Shoulder, sir. Shoulder, sir.
Shoulder or neck? Okay, this
Neck.
is the neck. This is the shoulder. This is the body. Okay. So body, shoulder, neck, and valve block. These are the four components. Body, shoulder, and neck into which the valve block is fitted by screw thread. What are the materials used in making the cylinders and why they are made out of that?
Molybdenum steel.
Molybdenum steel. Very good. What is the advantage of that?
It's lightweight and it can accommodate increased volume of
Tensile
gas.
strength is more. It can withstand pressure. Okay? So molybdenum steel with or without chromium, it increases the tensile strength and minimizes the weight and wall thickness. And what is the material used in MRA compatible cylinders?
Aluminium
cylinders.
cylinders.
Aluminium cylinder. Why it is used that? What will happen to iron if you use iron and steel?
Magnetic, sir.
Magnet
Magnetism.
will attract it. Okay, aluminium is not attracted by the magnet. So this is the MRI compatible aluminum cylinder where it will be written MR. So what are the types of pressure relief devices in cylinder valves? This valve is to have
Packed valve and sir,
fusible plug.
diaphragm valve, sir.
fusible plug. Very good.
Ruptured copper.
Okay,
Rigid
this
disc copper.
copper disc or a
Fusible,
combination of both.
fusible
Okay.
plug combination.
So these are the things which will prevent any blowout. They will leak immediately. Okay. This is the front and back of this block, valve block. This is called the stem, which you have to open to release that, and this is the port through which the gas will come out. Okay, and these are the two holes for the pin index. Okay, this will have this hole, and the pin will be projecting from the hanger of assembly. That this is the back side. This is the screw which will fit and hold the entire cylinder in position, and this is the pressure relieving device. In case of high pressure, this will rupture and let out the high pressure and prevent an explosion happening. Okay? So, what is the color coding for different gas cylinders? Oxygen, what is the color? Nitrous oxide, what is the color? Carbon dioxide, air, helium. There are so many gases which are used. So you must know the various color coding. So oxygen is white here, but internationally it is green. And in our country, we have black with white shoulders. Okay. And carbon dioxide is gray color. Nitrous oxide is blue. And medical air is black with white stripes. Okay. And yellow is for vacuum.
Okay.
Brown is for helium.
Helium.
What are the functions of this check valve assembly, which will be there in the hanger assembly to prevent any backflow occurring? So, this of course you will see only in the. What are the various sizes of cylinders, the capacities, pressure, and tare weight? This is another common question you may expect in the exam, and you have to know the answer. How are the cylinders named or sizes according to the sizes?
Double A to H.
Double A to H. Commonly used are B, D, E, F, G, H, and M. Okay. So B is supposed to be a capacity of 200, but commonly used cylinder is E type, which we use in our machines. It has a capacity of 60 liters. The pressure in which it will be filled is about 1900 per oxygen. And what is this tare weight?
Weight of an empty cylinder.
Empty cylinder, very good. So it is about 5.4. And what is the advantage of knowing the tare weight?
For liquid gases like nitrogen, we can measure the quantity of the left
How
of
much will
nitrogen.
be left? Very good. So it helps to calculate the amount of gas inside by calculating the total weight when filled minus the tare weight will give the weight of the gas inside the cylinder. And what type of cylinder is usually fitted in anesthesia machine? I told you it is the E-type cylinder. And this is the picture of, this is the E-type cylinder. It's not a E-type cylinder. Okay. Then what type it is there? From this difference in the valve, E-type will have the valve block what I showed you in the earlier pictures with the stem, that pin index pole. Do you find any pin index poles or the outlet port here? Yeah, yes or no at least?
No, sir.
No, you don't find that stem and valve block here, but it looks something different. So any idea what it is because? This is a B-type cylinder. Okay, this is a B-type cylinder, what is called the bull nose valve. And what is it used for? Commonly, in the smaller hospital, you will find it being used for oxygen therapy at the bedside. So you will, this will be the way you will have the to humidify that you will have a water container, you will have the pressure gas, and this is the handle to open that valve, and you can attach the oxygen tubing to nasal prongs or mask. The whole cylinder can be taken near the bed of the patient and you can give oxygen from this. Okay? So this is a B-type cylinder. It's usually used for bedside oxygen therapy. Now liquefied compressed gases at room temperature include the following. Choose the correct answer. Okay? It is gases which are compressed and made into a liquid at room temperature include the following. Which one? Which are all out of these four answers? Which are will be in the liquid form? You have carbon dioxide, you have
Nitrous
air,
and carbon dioxide.
Huh?
Nitrous and
Nitrogen,
carbon dioxide.
carbon dioxide.
A and C, carbon dioxide and nitrous oxide, both will be in liquid form, whereas air and oxygen will be only in gaseous form. So the answer is A and C. Okay. Now, what information is available from the cylinder label? You will have a label attached to a cylinder. So this will be the label that usually you see, and this is another common exam question they ask you. The information that will be printed on this label will be name of the contents inside the cylinder, the chemical symbol, physical state, whether it is a gas or a liquid, what is the total volume, whether it is flammable or non-flammable, what is the service pressure of the cylinder size code, whether it is B type, E type, G type, F type, and product license, principal hazards of cylinder and its content, date of hydraulic testing stamped on the cylinder. Okay, so these are all the information that we see. Now you find something here. This is the top portion of the cylinder. What does it show? Of course, from the color coding you can see this is oxygen and this is nitrous oxide. But what is the important thing that you see along with that valve block?
So pressure gauge
Pressure
Pressure
indicates
gauge
that
incorporated. Okay, cylinder with integrated pressure gauge. So instead of having a separate pressure gauge, the cylinder top itself is have a pressure gauge. What is the service pressure of a cylinder? Is the maximum pressure to which the cylinder may be filled at 70 degrees Fahrenheit. That is called the service pressure. So that you don't fill it too much to cause any explosion. How much more pressure they should withstand after the service pressure to prevent any bursting or explosion of the cylinder? It should withstand at least 1.66 times service pressure. Okay, that is a safety feature. So that, for example, if you say 2000 psi is the service pressure of your oxygen cylinder at which it is filled, it should be able to withstand another 1600 psi. So that maximum 3600 it should be able to withstand, even though you are filling it at a lesser pressure. So service pressure will always be lesser than the maximum pressure that you can do that, so that there will be no chance for explosion. Now you see a cylinder with a tag here. What is this tag for? It should always be there in all the cylinders, but majority of the times the OT boys or the people supplying that will simply tear it off and will not be there. But this is a very important component. What is this?
It is a tagged medical gas
Tag.
cylinder.
The cylinder tag to show the amount of gas in the cylinder. So this will have three parts. One is it will be full. This will be partly full, and there
In
will be
use and empty.
and there will be dotted line to tear it off. So what you should do is, when it is not attached to the machine and not in use, it should be in full form, which will show it is a full cylinder. Once you fit this cylinder into the hanger yoke at the machine, immediately you must tear this portion of full once you open the valve, because it starts emptying. So it will show partly full. And when the pressure gauge reaches zero and the entire gas is utilized, you must tear this portion also, and the empty portion should be left here and the cylinder should be removed. Okay? And left with the tag on, showing it is an empty cylinder, so that people don't mistakenly fit it again back into the machine. Okay? This is another safety feature to show the status of the cylinder. What is being done in this cylinder? It is looking like a flask. This is the portion which you see a difference between here and this. Is the valve block seen here in this?
No, sir.
People are not even saying yes or no.
No, sir.
No. So something is covering here, isn't it? Cylinder with protective cover for the valve. So no dust, nothing will open because the port is there. No, in the earlier picture I showed you, there is a port through which the gas has to come. The port can collect dust or oil, and that may be the cause for explosion. So to make it safe, you have to have this protective cover and remove this cover. Then this portion will come into view. Then you can attach it to the material. When you name the parts, this is the hanger yoke. Okay. Now, what are these two things?
Nipple,
These are the pins.
pins
This
and
is not the
nipple.
nipple, this is the pins. Okay. And what is this port? Or this
Nipple.
opening?
Body.
This is the entry port. Okay. Once you fix the cylinder and open it, the gas will flow only through this into the machine, to the pressure gas or pressure regulator. Okay. And what is this circular thing around this port?
Bodox seal.
Borax seal. Very good. So this is the pins for the index system. This is the nipple or entry port. This is the borax seal, and this is the retaining screw. So once you fix the cylinder, you tighten the screw, and that will hold the cylinder closed. Okay. So these are all the components of hanger yoke assembly, and this is the borax seal. With the borax seal. And, now again, I have shown this earlier picture. Borax seal is there. What is filling ratio? Why it is important? Now I can give you a small clue to answer this question. Some gases are in the gaseous form itself, like oxygen and air. Earlier we saw they are all in the gas form inside the cylinder. But nitrous oxide and carbon dioxide, once they are compressed inside the cylinder, they become a liquid partly. So lower part will be fluid and upper part will be the vapor. So now knowing that, can you answer this question? What is filling ratio?
The liquid gas needs some space for
Percentage of
gas to expand.
To expand. Okay, so you should not fill it up completely without giving any space for that. Okay, so to find out that, you use the filling ratio, which is the mass of liquid gas in the cylinder compared to the mass of water it could hold. So it is the ratio between the mass of gas that is there inside the cylinder, liquefied gas, divided by or below that the mass of the cylinder with the water filled to that level. Okay. This is important to allow the liquid to expand into gas at varying temperatures and prevent explosion. What is the filling ratio for nitrous oxide and carbon dioxide? The answer is that is how much percentage of the capacity you can fill for nitrous and carbon
nitrous is
dioxide.
68%, sir.
68% for both. Okay. Nitrous it is 7.5 in temperate countries and 0.67 in tropical. For carbon dioxide it is 68%. Okay. What are the tests done to check the strength of the cylinders, and at what intervals that should be checked? This is the
Every
knowledge
5
to know
years,
about
sir.
the safety. Huh?
Every 5 years, sir.
Every 5 years you have to check. Very good. What are all the tests that should be done? What are the tests that were done earlier, and what are all the tests that are done recently nowadays? Right, earlier we were doing what is called tensile test, flattening test, bend test, and impact test, where they will take a piece of the cylinder and hammer it, bend it, and they stretch it, and do all these things manually. That was the earlier method of testing the integrity of the cylinder. But now what they do, what is called hydrostatic testing, This pressure test evaluates the cylinder ability to withstand extreme operating pressures and detects potential leaks. And it must be performed every 5 to 10 years depending on the cylinder material. And also we are using ultrasound and visual and internal inspection, and active cylinders should be tested for leak using specialized soap solution also. And ultrasonic testing is also done to find out hidden cracks or corrosion in all the vessels. So these four tests were the earlier tests done: tensile, flattening, bend test, and impact. But the modern testing is hydrostatic testing, visual and internal inspection, including ultrasonic testing, and active cylinder testing using specialized soap solution. Name the parts marked here. Again, the same thing what we have seen earlier. This is the cylinder valve stem. Then there is a nut. Here also leak can happen. Right? So that will be the gland nut. Then there is the port for gas. Then there is the board seal. These are all the holes for pin index. And this screw only will be threaded into the neck of the cylinder. Okay? So this is the whole thing. And this is the pressure regulator, where you have reduce the pressure from high to low. And this you must be able to identify. Then they may keep you this as a specimen. What are all the things that, have you ever seen this? What are they used?
Yes, sir.
What are they used for?
To open the cylinder cracking.
This is open to, so you can put this hole here and turn it. Which way you turn to open, which way you turn to close?
Sir, anti-clockwise.
Anti-clockwise you open, and clockwise you close. Okay, so these are various types of keys to open the valve of compressed gas cylinder. This is the direction. So if you do anti-clockwise opening, it will open. If you do clockwise rotation, it will close. What is shown here?
Hanger yoke assembly.
This is the blacking plug or closing when there is no cylinder fitted into the yoke, hanger yoke. You should not allow that port to get exposed. You should fit it with the blanking plug. So dummy or blanking plug. And when can a wrong cylinder be placed in the yoke? There is a method of fitting a oxygen cylinder in a nitrous oxide yoke or nitrous oxide oxygen yoke. Is it possible? You can do that by two things. In a wrong cylinder
Forcefully,
can
sir.
be placed. If two washers are placed on the port, instead of one board of steel, you put two washers. Then still you can tighten and fix it. Or if the pins in the yoke are broken and the holes in the cylinder valve are too deep, then that also can allow the cylinder to be fixed in the wrong place. Okay. This is again a picture to show how these things are there. The board of seal. What is the feature of a board of seal? What are all the components? What is this black thing? What is the material it is made up of? Is it rubber?
Rubber.
It is not rubber. It is made up of durable, cold resistant elastomer called neoprene or nitrile, allowing it to withstand the extreme cold caused by the adiabatic expansion of the compressed gases. The neoprene core is encased in a peripheral metal reinforcing ring. This white thing is the metal ring, usually made of stainless steel, brass or mild steel, and this ring prevents the water from flying outward under high pressure. So that is how it prevents. And the materials are incombustible, that they don't burn. This is very critical when dealing with compressed medical oxygen. So burner steel cannot be burned. What is pin index safety system? We have already seen this is a interlink between anesthesia machine and the gas cylinder or pipeline hose block. So this is how the whole thing is there. What is the number used for pin index of common gases? It is given numbers 1:2, 2:3 like that. So what is the number for the oxygen, air and nitrous oxide, which are the three gases which we commonly use? Which
Oxygen
position
is
the
2
pin
is
will
to
be there?
5. Oxygen is 2 is to 5, sir.
So easy to remember. 1:5 air, 2:5 oxygen, 3:5 is nitrous oxide. Okay? Please remember these three values, which is commonly asked in the examination. The pins are placed as though they are placed in the face of a clock. So one position, two position, three position like that. So for air, the pin will be in one position and five position. And for oxygen, it will be two position and five. And for nitrous oxide, it's three and five. Okay? So that means the pin will come closer to nitrous oxide, and it will be farther away for air. That is how we remember that. And what are the dimensions of this pin? It is present in the underweight assembly. Length, circumference, it is 4 millimeter in diameter and 6 millimeter in length. Okay? So this is the size of the pin which is present in the underweight. What is the pin index for antenna? The length of the pin?
7 mm, sir.
7 millimeter. What is the pin index?
Don't know, sir.
It's a single pin, so there is no issue like that. Okay, so this is how
Okay, sir.
the pin of antenna yoke will be there. Only one pin will be there, and it is 7 millimeter long. What is shown here? Everybody should be aware of this.
APL valve.
APL valve, sir.
All the components you see, you should say. APL valve is only one part of that. What is this? You are using this machine every day. I can excuse you for the earlier ones, which are all from older machines, but this machine, no excuse. What is this gauge for, ma? This is the airway pressure gauge. Whenever you close this valve tightly and then press it,
Yes,
this
sir.
pointer will move to show what is the pressure in the circuit.
Airway.
Okay, airway pressure gauge. What is this?
This is the mode to change the mode from the ventilator and bag mask,
This is
sir.
the lever. It's called the
Lever.
lever to change from manual to ventilator mode or ventilator to manual mode. Okay, by flipping this lever, you can change from, so three components are there. APL valve, pressure gauge for airway pressure, and the lever for flipping from manual to ventilator mode. Right. What is this? This is the pressure gauge of the cylinder, what you normally see. But what is this picture is showing? It is the mechanism by which this pressure gauge works. What is that mechanism called? Or what principle?
It's a Brodol pressure.
Bowden gauge, Bowden. That's why sometimes it's called Bowden gauge also. And the unit of anesthesia machine consisting of a gas outlet, pressure gauge, pressure regulator. This portion is the pressure regulator, and this is the downstream pressure outlet. From here only it goes to the flow meter. So this is the entry point for gases from the cylinder or pipeline. Then immediately the pressure there will be reflected. That pressure is reduced by this pressure reducing valve, and this is then further downstream it goes to the flow meter. So this is the assembly you will see in the older machines and which will be hidden in the newer machines. This is again a head of a attachment where you can do what is called two-stage regulation. You can reduce the pressure to a higher level as to a lower level. So this is called the two-stage oxygen pressure regulator. And how much pressure reduction is happening by the pressure regulator from 2000 psi or 1900 psi from the full cylinder? What is the pressure to which it is reduced before it
45
reaches
to
the
50
flow
psi.
pressure? Huh?
45 to 50 psi.
50 to 50 psi. Good. So nitrous oxide will come to 60 psi. Okay. Who is this person? And what is his contribution? It is related to the earlier slide. What we just now saw. He is called Eugene Borden. Okay. He only designed the Borden pressure gauge. So what is the peculiarity about nitrous oxide pressure gauge?
Oxygen pressure gauge says about the actual amount of oxygen left over, but nitrous
Fantastic.
pressure gauge doesn't says about the actual leftover because nitrous it's present in liquid form. So
So it will reach the same pressure until the last drop of liquid becomes a gas or vapor. Okay, and then suddenly come to zero. So there is no point in having a pressure gauge for nitrous oxide. In the earlier machines we never had it. Okay? But the modern machines they have incorporated nitrous oxide also. Why? Even
because
though
it
it
comes
is going to
through
show the same pressure till the last drop is evaporated, but compulsorily they have incorporated the nitrous oxide cylinder. So we show the same pressure till the last drop of nitrous oxide evaporates, but we have included this mainly because in neuro anesthesia, the earlier days when we were using nitrous oxide, the sudden drop of nitrous oxide will make the plane of anesthesia very light. Okay. So as the needle starts declining, immediately you can open the reserve cylinder and maintain the same flow of nitrous oxide. Okay. And for cardiac anesthesia also, patient may become aware by if you cut off the nitrous oxide. So these are the two specialities for which this was included, but in practical use it is no big value. Okay. And these are all the entry point for machines from the outside where you use the diameter index safety system. Right plane pressure indicators are very important for telling the reduced pressure. This is the oxygen pressure gauge. So here it is showing all the features. The pressure is given both in pounds per square inch as well as in kilograms per centimeter square, and it is staying full when the new cylinder is fitted. The needle should point here, and when it starts dropping, it is showing the zone to refill and open. These are all safety features that are sometimes asked in the examination. Okay? So the safety features in these are all these things what is written here: no use, no oil, and the name of the gas is written there. And this is the working principle of pressure gauge, Borden pressure gauge. And usually the pressure gauges are color coded, and also the name and symbol are written over the dial. And the Borden tube structures, it went, all the gases will go only from the back side. It will not come through the front side. And it is written that no use no oil and open the valve slowly. All these are precautions that are done. Can you identify what is this? Any of you would have played with this as a child when you go for a festival or some village site?
we used to blow and it will give
This is called the blower or a party horn. Okay, this blowout or noisemaker or party horn. And when you blow through this unfolds like this from this rotated position, folded position, it unfolds. The same principle is involved here, Bowden gauge. Okay, that's why I have shown this. And one more slide, I think I will. What is the definition of a medical air? What we are using, there should be no detectable liquid hydrocarbons or gaseous hydrocarbons less than 25 parts per million, and particulate matter should be less than 5 milligrams per cubic meter, and normal atmospheric pressure and dew point at 50 points should be less than 4 degrees. What is critical temperature and critical pressure of gas? That's another physics question they will ask you. What is the critical temperature?
The temperature above which the
Gas cannot decide whatever pressure
Liquefied,
is
however
applied.
much pressure you apply, you cannot liquefy. Very good. That's called the critical temperature. And what is the critical pressure? And what pressure you achieve at the temperature is called the critical pressure. Okay? Critical temperature of a substance is the temperature at and above which vapor of the substance cannot be liquefied, no matter how much pressure is applied. And the critical pressure of a substance is the pressure required to liquefy a gas at its critical temperature. Okay? So that is the definition. How to calculate oxygen while using? Nowadays, every one of you are using a mixture of oxygen and the air in DOT regularly, isn't it? Many of you avoid nitrous oxide. But wow, how will you calculate the percentage of oxygen that when you use air as a carrying gas along with oxygen? You use 2 liters of oxygen and 2 liters of air, medical air. How much percentage of oxygen you will get in? How to calculate that? Of course, nowadays it is very easy for you. The monitor will show you what is the FiO2 and what is the expired O2. Everything is given in the monitor itself. But the calculation you have to know is, supposing you use 2 liters of oxygen and 2 liters of air, oxygen has got 100% oxygen. Okay? Whereas air has got only 21% oxygen. So for oxygen, 100 into 1 into 2, that is 100%. And for air, it is 0.21 into 2 liters. And the total volume that you are using is 2 plus 2 is 4. So for oxygen, it will be 100. And for air, it will be 2 plus 0 for 2 to 21 will become 0.42. So multiplying all these things, you will get roughly 60.5% oxygen if you use 2 liters of oxygen and 2 liters of air. Okay? That is how the calculation is done. And last slide before we close, this one is adiabatic and Joule-Thomson effect. This is a common, again, often asked question in the examination. Adiabatic change and Joule-Thomson effect are, the gas is subjected to sudden compression from normal pressure. There is heat energy produced, and when you release the compression from a compressed state, heat energy will be reduced. And these two changes are called the adiabatic changes, but there is no exchange of energy. And this can be one of the important reasons for any explosion to happen. That is the reason why we should not allow any oil or dust to happen in the entry port or exit port of the cylinders, and we use the hanger use assembly. Okay? And the Joule-Thomson effect is when a gas is allowed to express through a narrow opening, the surrounding temperature will drop, and that will cause the water vapor in the surrounding air to condense into ice formation. So this can happen on the cylinders of nitrous oxide. When you open the cylinder releases the gas under pressure or the vapor under pressure. This will cause a sudden drop in temperature at the point where it is exhaling, and that will cause cooling of the air surrounding that well block, and that cooling will cause the water vapor to condense into small ice particles that will get deposited on the cylinder valve and the body. That is called the Joule Thomson effect. Because nowadays we don't see all these things because all the gases temperature overall very regulated, and use of nitrous oxide is also slowly going away. But to pass your exam, you have to definitely know this. I think I will stop here and we'll continue next week. Okay. We have already gone beyond 8 o'clock. So can we stop here?
Yes,
Okay,
sir.
sir.
Thank you, sir.
Lot of things to go ahead.
Thank you, sir.
Okay.
Thank you, sir.
You can
Thank you,
send
sir.
the feedback to me. The what whether we have to improve on this or whether it is useful or boring. Whatever you want to say, please send me the feedback. We'll adjust accordingly. Okay.
Thank you, sir. Thank you, sir. Nice, sir. Very useful,
Thank you,
sir.
sir.
Very useful, sir.
Very useful, sir.
Thank you very much.
Very useful, sir.